It's an honor to be here. I know that many of you have walked the same walls I have, and I really am just appreciative that I could be here and talk about bats. This is the mission statement that we as a program follow, and it's been up here for a while, so I'm not going to read it in front of you. But I'm a northern Wisconsin guy, trapped in Madison, but I do love it here. My family is here, and it's a place that I really enjoy. But today I'm here to talk about bats, and as Mark said, there's lots of different ways to study bats. There's a lot of ways to think about bats, and I'm sure at a moment's notice I could say, hey, anybody tell me 8 species of birds, and you guys would be able to rattle off chickadee, crow, all the turkey. But it would be pretty hard pressed to see how many bat species we have in the names. So we're trying to kind of get over that hump of getting more information out there and letting people know that we have a lot of different species, and these are the ways that we protect them and study them. But as far as what I'll cover today, bat species of Wisconsin, the threats that face Wisconsin's bats, and some notable projects that we've been working on. And certainly towards the end of, it sounds like we're going to be doing questions at the end, and I'll do my best to repeat those for the camera, but please just, hopefully you come away with more answers than questions, but please just save your questions for later. And there we go. So Wisconsin bats, they all share a few common themes. They're all insectivorous, so that means they're eating insects. They're echolocating to capture those insects. So they're sending out sound pulses, listening for those sound pulses to return, but not only navigating the dark night sky, but also eating a variety of different insects. Insects that both benefit us in the sense that they eat mosquitoes. They eat up to 17 different types of mosquitoes, some of which have West Nile virus. Or forest predators or agricultural predators as well. And so they're a voracious predator. They're the #1 nighttime flying insect predator in Wisconsin. And so they're incredibly hungry. You probably have heard some of the stats, right? A little brown bat can eat up to 1,000 mosquito-sized insects in an hour. A little brown bat can eat up to its body weight when it's nursing. So, which doesn't seem like much, but when you talk about an 8-gram bat, extrapolate that to, say, me, for example, that's about 600 quarter-pound cheeseburgers every night. Do that over and over and over again. That's quite a few cheeseburgers, right? And then all of a sudden pack 50 or 100 bats in a bat house, and they do a lot of good on the landscape that we walk. And so to introduce you to the Wisconsin bat species, maybe I'll take a step back and say that we just recently, when I say we, the collective bat community, just went over 1,500 species. So when I first started studying bats in 2007, there were 1,100 species. So they continue to find them. They're obviously not being found in Wisconsin, but they are found in the warmer parts of the world, close to the equator, where you would expect to have a lot of species richness, a lot of species diversity. And so while there is incredible diversity and species richness around the world, we have a modest 8 species. And it wasn't actually until recently that we only had 7 species, and it wasn't until 2015 where we actually found the first mammal species since 1950. And that was the evening bat here, actually found on one of the properties Mike Foy was a manager of.
Completely responsible.
He's completely responsible for it. He asked us to rename the bat after him, but we decided not to. Anyway, so our Wisconsin bats, they can loosely be categorized. They fit into 2 nice categories: the tree bats and the cave bats, although it's a bit of a misnomer because all bats use trees. These are the ones that primarily will leave Wisconsin. So many of our Wisconsin people will decide to leave because it's just too cold. The same with this half of it. They will continue to go to Florida, Mexico, even Missouri, looking for insects that they can continue to forage throughout the year. Whereas these other bats, these are the bats that are looking to find a cave, a mine, a hibernation site that's suitable that they can spend the next 6 to 7 months of their life underground when insects just aren't available. I just wanted to show, this is a really neat picture of an eastern red bat, and usually we're walking around the woods looking for them, but in some cases we help with the aid of radio telemetry. You can see a long antenna here, and that actually helped this researcher find that individual hanging in the tree. So we use a lot of different techniques to find bats, and that's just one of them. Of course, it's not the same as the radio telemetry of deer, right, where the size of that would be 20 different bats, but it's a very small and it's limited by the battery size. And so the cave bass, to kind of zoom in a little bit, we've got 4 species, like I said. These are all considered state-threatened species because of the threat of white nose syndrome, and I will go over that in some detail later. And so are the bats that you probably would recognize because they're the ones that come in contact with us more than others are the little brown bat and the big brown bat. A big brown bat is affectionately called the house bat. So they're the bat that's going to get into your home, get into your attic. Same with the little brown, but in the winter, big browns are the ones that people will find. You know, they'll go into their holiday decorations and pull out a little brown bat, or sorry, a big brown bat. And what you'll notice here is the theme is that they're not very colorful, right? They're all very drab looking. Some might be a brown to olive brown, some might be russet color. But when you look at the background, a cave or a mine, it actually looks very similar. So they're actually very camouflaged, and you need to be that way for 6 to 7 months when you're spending that much time there, basically idle. You might wake up every 15 to 20 days on average, but typically they're spending their winters in stasis. And so this is the tricolored bat, or eastern pipistrelle, as Mark had mentioned. Each one of these have different preferences on how they'd like to hibernate. This one we call the grumpy bat. It likes to be alone. It doesn't like to be by anybody else. This one doesn't mind being clustered or huddled with other bats. This big brown bat is kind of the exception to every rule we have for bats. They'll be found in a cave, but they'll also be found in your attic. They'll be found in very cold environments where you wouldn't expect to find bats. Often when we find these bats, they're either at the entrance of a cave or a mine, or in some cases in an attic or a crawl space, and they're right at freezing temperature. So just above 32 degrees, but they can go all the way up to 50 degrees. And then there's the northern long-eared bat, as you might expect. They've got really long ears. And they use those ears to whisper in the night sky. So they actually have the ability, what we call a whispering bat, where they're sending out pulses, and sometimes insects will actually listen and hear echolocation calls, and they'll become quiet. And what they do is they turn down their calls so then they can actually hear the insects, whether they're on the foliage or whether they'll often eat spiders that are inside webs and stuff like that. And so that's our northern long-eared bat. They'll often, when they're in a hibernation site, they will roost in caves and cracks and crevices. So very hard to see, and you might only end up seeing just a part of their ear as you look for them. And then our tree bats. Again, the theme is very colorful, right? So these spend a lot of their time inside trees. An eastern red bat hanging by 1 foot might just look like a dead leaf hanging in an oak tree. A silver-haired bat will often roost behind tree bark, and they've got that nice silver, almost like gorilla type pelage. And then you've got the hoary bat, which is the largest bat that we have in the state, and that's anywhere from 15 to 16-inch wingspan. They'll often look like a pine cone hanging in a pine tree. And then here's the evening bat. It looks more like a cave bat, but it migrates out of the state entirely, even though it is found here in the summer. And so why do bats need protection? Well, they need protection from, kind of the usual suspects: habitat loss, destruction. They concentrate in parts of their life, whether it's in the summer at somebody's bat house or a barn, or in the winter when they're sitting in these caves and mines idle for 6 to 7 months. And so they're very vulnerable in that regard. Human interaction, whether people are trying to get them out of their home by evicting them, they might do that during the wrong time of year, where if you put up an eviction tube and try and get bats out during, say, the middle of June, you run the risk of allowing females to leave the adults, but then leaving the flightless pups behind. Typically, we say June 1st is kind of the bat birthday, where they give birth during that time, and it takes 3 to 4 weeks for a pup to start to fly. And so at that point, they're very reliant on their mothers. Unfortunately, the dads are kind of out of the picture. They're kind of the deadbeat dads of the world. But really, the females take on that brunt of nursing and raising their young, and then eventually teaching them not only how to fly, but also to forage and capture insects. And so, some of these other, pesticide impacts, and then climate change. We're still trying to figure out where the winners and losers are, but we expect that there's definitely going to be more losers than winners with climate change and how that might affect Wisconsin's climate. And then probably the biggest two factors or two threats are wind farms to bats and the disease white-nose syndrome, which I'll just briefly talk about here. So white-nose syndrome was first found in 2006 and 2007 in a popular caving destination in New York. It's a fungal disease that lives in cold, dark, damp places, which unfortunately overlaps exactly where bats need to hibernate during that 6 to 7 months. As you can see, it's known for the growth not only on the skin, the muzzle, the nose, but it also grows readily along any exposed skin membrane. So ears, forearms, uropatagium, which is that flap of skin behind their tail. And so it readily grows on there. It irritates them, it wakes up. These bats are waking up, like I said, typically in a normal arousal period, it's anywhere from 15 to 20 days. Bats with white nose syndrome will wake up 3 to 5 days on average. So they burn through those fat reserves that they need to survive. And when they do that, they run the risk of starving to death. And so in many cases, they're leaving a hibernation site much earlier than they should be in February, in early March, and they end up dying on the landscape, or also exposure to predators that might be waiting for them. Hawks, raccoons, and a bat flopping on the snow is a really easy target for some of those critters. And more than half of the bats that utilize North America rely on hibernation as a strategy, so it really is a big deal. 12 species have been found to be affected by white nose syndrome, all of which, the cave bats that we have, 4 of which are affected by white nose syndrome, and you can see that it includes some federally endangered species as well as federally threatened species. It's confirmed in 40 states, in 9 Canadian provinces. It's on both coasts. Like I said, when it first started in 2006, 2007, it spread along that Appalachian Trail to where it eventually got into the Midwest in around the 2012 time period. Wisconsin was first found white nose syndrome in 2014 in a far southwest part of the country, or in Wisconsin. And so the status today, and I'm not putting big browns up here because big browns, like I said, are kind of the exception to the rule. They're not as affected by white nose syndrome. We believe that's because they're a much larger body. They choose to hibernate in those cold conditions, which the fungus doesn't like as much. But these other species are heavily affected. Northern long-eared bats, 99%. Tricolored bats, 90%. Little brown bats, their populations have dropped by 75%. And so it's very likely within my lifetime and within your lifetime that we may see local extirpation of tricolored bats, of northern long-eareds. The tricoloreds are already on the edge of their range anyway, really primarily found in the southwest part of the state. But northern long-eareds were ubiquitous. They were found throughout the state, never in large numbers, but they are heavily affected by white nose syndrome. And then little brown bats, they're probably our only success story, if you can call it that. Where, like I said, their populations, they started at the highest. There was approximately anywhere from 300 to 400,000 little browns that we knew about prior to white nose syndrome, and that population has since been reduced by 75%. The good news, and this is kind of a busy graphic, but what I want you to point to is this graph here shows summer colonies. This is winter colonies. This represents 39 summer colonies, 46 winter colonies. This is population growth here. The dotted line is a stable population. It represents a stable population. The x-axis is years since white nose syndrome was first found. And so we have a really good picture of what was there before white nose syndrome, what was happening during the invasion or decline of white nose syndrome, and then what has happened since. This map represents the distribution of those sites throughout the state. And as you would expect with the unglaciated area, the area where there's a lot of caves and a lot of mines, that's where a lot of our sites are. And so the bottom line is, what this shows is they almost mirror each other, right? Where the summer is reflective of the winter, where prior to white nose syndrome in this purple, they were actually doing well. In some cases, we saw populations increase. White nose syndrome hits year 0, that's where things start to decline, where we've got year 2 and 3, were the most precipitous declines that we saw by this of that disease. And then the preceding years, we're starting to see that rebound effect, where we're starting to see more of a stabilization. In fact, in some cases, an increase. This is just for little brown bats. So this is not representative of all cave bats, but this is showing that we are kind of at that period where the bats are tolerating the disease a little better, whether it's through genetics, whether it's choosing the sites carefully, but they are somehow tolerating the disease. We've actually put small transmitters on them and been able to understand their arousal periods. And so, like I said, during white nose syndrome, these first years, they were waking up 3 to 5 days. Now they've been able to actually extend that to where it matches more of a normal period. So now they're able to do a normal arousal period, so 15 to 20 days. So now they've been able to tolerate this disease a little more. We don't think that they're resistant by any means, but they're able to tolerate in the face of this disease. Wind energy, we definitely want sustainable energy, but we realize that wind energy can affect bats. We can find bat fatalities not only beneath them, but in some cases far off beyond the rotor swept area. It primarily affects tree bats, but we also know that it will affect bats, cave bats that are near hibernation sites, but also near summer roost sites. And it primarily seems to happen during the late summer and fall when we have a lot of bats on the landscape. Bats are leaving their summer roost sites looking for hibernation sites, but they're also leaving the state entirely. And you have a ton of juveniles now on the landscape, so we have a lot of teenage drivers and they don't know how to fly quite yet, right? So they might hit these turbines more readily during that time. So some of the ways that we can actually stop or mitigate some of the effects from wind turbines is siting them in the right spot. Department doesn't actually have authority over that. That's more of a public service commission type thing or a local ordinance, but we can recommend don't place it near a hibernation site. Don't place it near a maternity site. But we also have the ability to dictate what they can do with those turbines. So we call it feathering or smart curtailment or curtailment, right? Where in low wind speeds, when we know bats are flying, as bats are flying through these areas, they're more prone to getting hit by turbines. And so if we can actually put the brakes on those turbines at a point in which we think that the bats will actually not fly through there, then we can do that. And so this curtailment is a way to actually mitigate that. And so we have since created, just last year, a broad incidental take permit, which puts regulations very similar to federal guidance that not only it recognizes the importance of wind energy, but it also acknowledges that they could be detrimental to cave bat species. And so what we do is we're putting buffers around cave bat hibernation sites, but as well as maternity sites. And so if you're within those areas, you have to follow strict regulations. You have to curtail during the certain times of the year or at certain speeds to mitigate against any mortality. And then you also have to monitor, within the next 2 years, monitor those sites to make sure that you're not having any great impact on local populations. And we expect that the fatalities will drop at least 50% within these next few years because of the broad incidental take that we've just put into place. And it's yet to be implemented, but this year is the first year that they'll have to implement these changes. And again, put the brakes on some of these turbines during the times in which we'd expect bats to be flying through. Our current projects, I'm excited to say that we've got 3 long-standing citizen-based monitoring projects. Acoustic bat monitoring, that's what Mark was talking about. We're giving people the opportunity to use acoustic detectors to listen for bats on the landscape. It's a great way, not only as an educational tool, but it tells us as a department where bats are in the landscape and which species are in relative abundance as well. And so that's our longest running project. It's been running since 2008. We primarily have about 400 surveys done per year. A lot of them are up north in Vilas, Oneida County, which is really great to get some of those lakes surveyed. And then we also have a sick and dead bat reporting form, which is really great not only for us to be able to respond in real time to bat mortality events, but it also helps us collect carcasses and help contribute in various ways to research projects. And then the bat roost monitoring project, again, very successful. We get about 350 per year. And these, we're asking folks to sit outside their barn, sit outside their bat house, and count bats as they come out. It's similar to like the Great Wisconsin or bird count that happens in Christmas. We have a Great Wisconsin bat count where early June and then middle part of July, we ask people to monitor their roost sites. So they sit there and with their favorite drink, cocktail, and they watch bats as they come out, and they count that before the pups have started to fly, and then after that, in July, they can actually see a little bit of a population increase based on how many pups are now flying. And then some of the other projects that we've been really trying to focus on are bat education. The early years, kind of during and before white nose syndrome, we really focused on bat festivals, which was one-day event where we had people that wrote books. We had authors, we had a bat cave, we had live bats, we had fruit bats, we had all kinds of different bats where people would come in and learn all about bats and bats of the world, but also bats of Wisconsin. That was primarily focused in Madison, but also in Milwaukee, and we had one up in Ashland. But then we kind of shifted gears and said, well, we're still getting calls from people and asking, can you come to our school? Can you come to our nature center? How do we serve those folks? Well, we tapped into the Master Naturalist program where we developed a day-and-a-half curriculum where we teach master naturalists that are interested in bat programming to go out and basically be train the trainer. So they're going out and they're going on our behalf and talking about bats in a variety of ways, to whether it's hosting an acoustic event or watching bat roost monitoring, or talking to that nature center or talking to those schools. And so since we've started in 2023, we've had over 100 folks log in 1,200 hours and at 290 events. So we can kind of be in, there's 3 people that work with bats, or at least partially with bats in Wisconsin, DNR. We are fortunate to now have so many others that are working with, so we can be in a lot of different places at once. And then our other projects, we're just focusing on white nose syndrome, bat ecology, and the natural life history. And I'm gonna, it's not working. There we go. So in light of white nose syndrome, we really wanted to figure out how bats are surviving, which bats are surviving, where they're going, and what's the longevity of these bats. And so similar to, say, how you would track a cat or a dog, they use a small pit tag, right, the size of a grain of rice. We can use that in the same way. We can either inject it into the subcutaneously into the back, or we can glue it right on the outside, so we can then track that individual. Traditionally, what we've used is small little bands which go over the forearm, similar to how a bird band would be. The problem is you then need to you have to handle that animal again. And once a bat leaves your hand, there's a good chance you'll never see that bat again. So it's really challenging. Typically, we get a 5 to 10% recovery rate on banded bats. Whereas if we pit tag bats, it's anywhere from 35 all the way up to 83% recovery rate. So this requires us not necessarily to handle the bat anyway. We can use either stationary readers or handheld readers. And again, PIT means passive integrative transponder. And again, it's the same technology that's used to track your dogs and cats if they get lost, and the Humane Society can scan it. And so this is a variety of different deployments. Somebody had mentioned Need a Mine earlier. There's Need a Mine with a bat stationary monitoring device sitting on top of there. And so anytime a bat flies through those openings, it gets read by our stationary recorder. Here's a set of bat houses, and we have stationary readers on there. So anytime a bat comes in and out and is tagged, it sends it down to that down to the reader there. Or you can handheld read it too. So this is a handheld reader, and this gentleman is just scanning the outside of those bats, and then we can determine if there's any pit tag bats in that area. What we're learning is that these pit tag bats can travel a long way, but they're also very intricately connected to other roost sites. So the orange or yellow are summer roost sites, and then there's 3 diamonds, and those are our hibernation sites. Collectively, those 3 diamonds hold 99% of our cave hibernating bats. So it's great, but it's also kind of bad to have all your eggs in 3 baskets, right? But what this does is it shows us, hey, picnic point bats, do they just go to Nita? No, they actually also go to Pierce County. Are they aware of other roost sites? Yes, they do go to other roost sites. And so it really is, it kind of starts to uncover a lot of interesting things that we would never be able to do if we were just trying to find those bands, right? Trying to recapture those bands. So this pit tagging and reading and having these stationary readers without us having to be there has been a game changer for us. It doesn't allow us to radio track like you would expect with other technologies, but you do have to go through those readers. But we have enough readers now on the landscape where we're actually tracking these individuals, which is really neat. We've gotten over 40 different connections back and forth, whether it's from a roost site or to a hibernation site. And so what we could also do is use that, we can leverage the pit tag data, the pit tag bats, to look at when they're using hibernation sites. And this is a graph that shows basically that. It shows all the pit tag bats using hibernation sites. And so what you can see is from August to October is the greatest period of activity around these hibernation sites. And it makes sense because they're not only looking for a place to hibernate, but they're also mating during that time. And so that's when it's most active. They'll certainly stay around some of those hibernation sites in the summer, and those are primarily males. But for the most part, the most active periods we're seeing are in the fall. And again, that makes sense biologically for them. And so what we did was we partnered with Virginia Tech, a PhD student, to look at these. So now we know that white nose syndrome has shrunk these populations down to over half of what they used to be. How do we monitor these? How do we protect, safeguard against other potential mortality sources? So is predation an issue? And so he set out trail cameras at entrances to all of our major hibernation sites for 3 years, and watched and had 30 seconds worth of footage anytime an individual would go through. He identified 3 major characters that were eating bats, or at least hunting bats: cats, raccoons, and owls, particularly barred owls. And the worst offenders were cats and raccoons. Raccoons were by far the most efficient predator, but cats, they would stay there longer and eventually capture them. And so we also saw some learning behavior, or teaching behavior among cats too, where they would bring in young and they would show the other cats how to catch bats, because in many cases a lot of cats just weren't very good at catching bats. But in some cases there were a few that were really good, and they actually taught their offspring how to do it, which is unfortunate. But again, we hours and hours of footage. He watched all these individuals and identified this. And what he did notice then is that the gray is when a predator is near the hibernation site, but it's in neutral. It just happens to be walking through. It's not actively hunting. But then he looked at when they were actively hunting, when they were actively capturing bats, and it overlapped perfectly when bats are using these sites for hibernation, but also for mating. And so that was a big concern for us. So now that we've noticed, we have the major predators involved, what can we learn about that? And this is just an example of, hopefully it shows up. This is a video. What you'll notice here is a cat hunting. This would be one of those red dots, right? And yeah, so a few things to notice, just all the bat activity around there. You can see all these bats flying around, captures it, knocks it down, right? You'll notice it didn't have a collar on it. A lot of feral cats in and around this area, but we also have collared individuals as well. So the bat activity kept active even in the face of a predator. And that's what this student started to notice. And he wanted to test, additionally, what would happen if you put a cat there, or a raccoon, or an owl. And that was our next project. And so what he did was he created a Y-maze study where we gave the bats the option, go into the left or go into the right. And we put either a cat or a raccoon or an owl or a stump as a neutral, as something that's a control. We also put a cat that had a bell on it as well. The bell would go off every 2 or 3 seconds and would rattle. And so, probably the hardest part of this whole project was actually trying to find cats, because we got laughed off of email chains asking if anybody had a mounted cat. And so we eventually found some in Missouri where people would like to get their pet mounted, and these just happened to be individuals that they never picked up again. And so we were able to find these, and again, they're not live, but they are very similar in every way. Very large tomcats, and then you've got the raccoon and a barred owl. And so what we found is, again, you're pitting one predator against another, or one control against another. And so the most important findings were that the bats do actually avoid raccoons compared to cats. So they recognize raccoons as a natural predator. Cats, they do not recognize. But when you put a cat against a cat with a bell, they completely recognize that bell, and they go to the cat. So there's ways that we can minimize bat predation around these areas, whether it's finding cats and putting bells on them, or asking landowners to keep their cats in during that time, or like I said, put bells on there, or maybe local trapping efforts to try and get raccoons out of that area. And they also didn't seem to recognize barred owls as predators as well, which we thought was interesting as well. And then the last project that I just wanted to mention was just discussing, to end on a high note, discussing some bat activity that is kind of interesting in the Milwaukee area. Again, when you think of Milwaukee, you're not thinking great bat habitat, but during migration, anything can happen, and it could be a great stopover place. And that's exactly what we found here. In the fall of 2023, I was alerted, called in the middle of October by a land manager that owned I don't know, 5 or 6 different buildings and said, hey, I've got bats in these different places. Some people would like them removed because they're right inside, right where the door is. They're right by the handle. Could you at least come check this out? So I investigated. In the course of an hour and a half, I found 22 bats. And not only bats, but silver-haired bats, which was really neat. And so that kind of brought us to this realization that this might be some sort of stopover point, and how can we investigate this further? And so we used the team of master naturalists last year to go out weekly over the course of October all the way through the first part of December and do a circuit around Juneau Park to see if there are bats and where there are bats. And these are the findings here. So through the course of 2 months worth of surveying, we found a total of 86 silver-haired bats, 5 big brown bats, and then 2 eastern red bats. On an average trip, they would find nearly 8 bats. And they would, usually when they're finding them, they're either on trees, of which they use 10 different species, or they were on buildings. And then when they were on buildings, they were mostly using these red raked faces. And we think that has a lot to do with the thermal energy that not only holds, but that it radiates back to the bats. So super important, especially as you get colder, right? So the coldest day that we found a bat actually roosting on a building was 26 degrees. So very cold, but when you're on a building like that, it does buffer the temperatures quite a bit and it radiates back. So this is something that we're using citizen-based science to go out and look for bats and try and understand a little bit more about it. And can we do something going back, can we do some sort of press release to the Milwaukee area to let people know during that first part of October, hey, there's bats moving through. If you happen to see them, don't worry about it, send us a picture. They don't need to be sent to rehab, because that's also what was happening too, is people were picking up bats on the building and say, this bat is sick, this needs to go to rehab. They were either submitting them for rabies testing or sending them to rehab, and rehab is already taxed because they're doing a lot of different things. They don't need a healthy bat to look at and then eventually take off. So are there ways that we can minimize these types of things? And so that was this project here. I think I kind of burned through it really quickly, but I'm sure you guys will have a lot of questions, so happy to talk through those with you.
Thank you.
Yes?
What percent? How prevalent is rabies?
Rabies?
Yeah.
Yeah, so we say it's less than 1% of the wild population. Within Wisconsin, typically 800 to 1,000 bats are submitted every year for testing. Those are primarily juveniles found in the fall, right? So they're not knowing the entrances, the exits, they slip into places they're not supposed to, and so they're very vulnerable. But of those individuals that are either found on the ground or found in a house, it's typically 3 to 5% of those individuals that are rabid. So it's very low percentage, but yeah, ultimately that's on the forefront of a lot of people's mind for sure. Yeah.
Any luck making artificial inner habitat for cave bats?
Artificial.
Habitat for cave bats?
Yeah, we've dabbled in that a little bit, but we haven't. So, sorry, the question was any success in creating artificial habitat for bats. I would say that overall humans are really good at creating holes in the ground, and the 3 mines are just representative of that. So we don't necessarily need to create any more that we've realized. In other parts of the country, so like Tennessee, they created a bat cave in the idea that in the face of white nose, if they could try and get bats in there, that during the summer they could go in there and spray it down to get rid of all the fungus. Unfortunately, even right next to a site that had 80,000 bats, they couldn't get any bats to come over. They piped echolocation, they smeared guano in there, they even translocated bats in there, and it wasn't really sticking. And so bats go where they want to go, but we haven't really had much success or really tried to create artificial hibernation sites for bats. One good example that we have used, like locally, again, people contact us all the time in the middle of winter, hey, I've got this big brown bat, but folks are really hesitant on releasing that bat in the middle of winter. They don't understand that most bats are all big brown bats in the middle of winter, and so they're worried that if they release them, they're going to die instantaneously. And so we try to educate them that that's not the case, but we also use artificial sites. So there's a site in Owen Park that was a whole former cave or a former beer cave. And so we actually have created a site there that is what we call a soft landing. So anytime a rehabber gets a bat in, they look at it and say, this bat is fine, I want to release it. If the conditions are suitable, they'll put that bat in that cave and at least have an opportunity to be warmer, and then have it choose whether it wants to stay there or whether it leaves. And we actually have a pit tag system on that cave, so then we can determine how long they stayed. Is it because all of a sudden you had a cold front and they did stay for a week, or did they stay there the entire year? So far we've found that they really don't last very long in there. They use that as a kind of a resting place to get their bearings, and they eventually take off, but it does help people feel a little better that they're not just putting them out in a cold landscape. Yeah.
You talked about pit tags,
Yeah.
and now with the advent of increased technology for radio transmitters on butterflies,
Yeah.
are you going to get them on bats?
Yeah, so we have explored, again, the problem is the battery life, right? And so that has been an issue with trying to track these bats over a long range. And so some of the things, and you guys are probably very familiar with this, is MODIS, and trying to find, using that technology, because there's towers everywhere, and can we put tags on there? Again, I think that they're still a little big for what we would want, and you have to actually change that pulse rate to go on every so often, whereas if a bat is migrating through, they might be out of the state within a couple hours. And so we've definitely looked into different tags, and we're always trying to minimize the tax that we put on these individuals. So we're always remaining at least 5% or lower of the body weight. And so whether it's a band or pit tag or a radio telemetry unit, we're always looking for ways to try and minimize what we're putting on those individuals. Yeah, Mark.
Where the cave bats go before there were sand mines and the iron mine?
Yeah, no, it's a good question. I mean, we don't really have a great sense of that. There were certainly a lot of bigger trees in the landscape before mines, right? And so big hollows, and that could have potentially, and you have tip overs, so you could have a lot of different spaces. But yeah, that maybe we artificially created, a great bat population just because we had these sites too. Hurley used to be a great example of so many different mines up there, and all of a sudden, that mining stopped in the 50s and 60s, and all of a sudden, all those sites that, miles and miles deep that they were continually pumping to keep water out, they filled up. And there was a news article that we were trying to actually track down, but it talked about how in the middle of winter, they used a front end loader to clear all the bats that had been flooded out of these sites. Because again, if you build it, they will come. These mines that bats were using, and then they stopped the pumping, and then all of a sudden it filled up with water, and then they flushed them out onto the streets. And so it doesn't take them long to find some of these sites, and if they're really intricate, and if they're miles and miles like these three large hibernation sites are, they offer a lot of different microclimates within those sites, and they're very appealing to those bats.
What's the trigger for coming out of hibernation?
Yeah, that's a good question.
The question is what?
Yeah, sorry, yep. What is the trigger for coming out of hibernation? So it's likely has, day length is something to do with it, a change in temperature. So as we know that even when these large sites where there's miles and miles of tunnel, and they might be in the far back reaches where there are no twilight, there is no light available, in the spring they actually move closer to the entrance, where they can actually start to feel that ebb and flow of spring weather. And so we think it has something to do with the barometric pressure, but also daylight conditions. And they're constantly checking it out. We know that through these pit tag systems where they go out, check it for a little bit, and come back. So that's one of the biggest concerns with climate change is worrying about those early springs where you might have a real early spring in March. All of a sudden you've got a huge insect hatch, and then which doesn't exactly time when bats would normally come out. And so if they come out in April when they were expecting a large insect hatch and it happened 3 weeks ago, that's a big deal. But it does seem to be day length, but also temperature, and then it depends on the site too. If there's drawing in warm air, they might be able to sense that and then go out. And these mines are really great for that. Yeah?
Can you kind of go through the phenology of bird and bat migrations, and whether they use the same sort of fallout sites?
Yeah, ask. So I'm not. Sorry, repeat the question. Looking for some phenology about bird and bat. Are there important stopover points? Is that what you're at? Yeah, so important stopover for birds are more well documented, right? We know that they need to rest, refuel, and then take off. We don't have a great sense of that for bats, and that's something that a smaller tag tracking them during migration would actually benefit. There's anecdotal reports of a sea captain, going across Lake Michigan and all of a sudden have a slurry of bats just, on top of them. So like we do know that it's in some cases, whether it's weather that brings them down or whether that's refueling, they need to stop in some cases. We do know that in the spring, it's less likely to have stopover events. When they leave, they go. And they're traveling very fast, and within a couple days, they're nearly to where they want to be. And we know that through radio telemetry, where we capture them, we put small tracking devices on, and then we chase them with cars, right? Or planes. And you guys have probably done a lot of that yourself. But it's a kind of a mad scramble to try and find these. But we don't have a great sense of the migration stopover points because they're just a little harder to track than birds at this point.